everyone, welcome to the video. We are going to solve a very common question in interviews, longest increasing subsequence. To begin with, subsequence need not be a continuous sequence of an array. Okay, so continuous sequence is subarray, but subsequences are not continuous. Okay, so we can take any random numbers as soon as they are starting from the zeroth index and they are between the or at the last index. Okay, so here in the example one, you can see if you take 2, 3, 7, and 101 in this way, you can ignore 5 obviously. In this way, you will get longest increasing subsequence of 4 length. Okay. Similarly, in example 2, you can see you can take 0, 1, 2, 3. Okay, 0, 1 from the 0th and first index, and 2 and 3 from the second last and last index. And similarly, in example 2, example 3, all since all the elements are same, so they are not increasing, and we have to find only return only strictly increasing subsequence. Okay, so they are not strictly increasing. They are. I agree that they are not decreasing, but they are not increasing either. So length will be 1. We won't count it. And I will be solving this question using DP and not recursion. So first of all, I will store the length of the given array in a variable n. Then I will create a DP. I will store initialize the DP with 1 because see, even if there's a single character in the nums array, it will return a length, right? So in example 3, you can see since there are more than one element, but still since all are same, so there will be longest increasing subsequence of length 1 because single number will always count a subsequence. Cool. And you can see it is given in the constraints that length of the nums will always be 1 or more, will never be less than 1. Okay, there won't be any empty array in this example as per the constraints. So I will create a dependent loop starting I from 1 to nth position, and j will depend on I. So j in range I. Okay, so once at I we are at ith index, j will start from 0th index to the very last ith index, which currently I is no less than I. Okay, previous index of I. Okay, now we will check one condition. We will actually check two conditions. So to begin with, we have to check with nums I greater than nums j, which means if current character is greater than the previous or any of the previous characters. Okay, and apart from that, even the second step, we can reduce it and we can write in the substituting condition. But to make the solution very clear and easier, I am including in the if condition itself, which is dp I less than dp j plus 1. Okay, we can anyways include that is this is a statement in the max kind of a statement, but I'm excluding that to make it easier and simpler. So to begin with, here is dp ith index. Currently, the current index of dp is less than dp j plus 1, and which means there is possibility to increase the length of the subsequence. Okay, in that case, what we will do, dp I equal dp j plus 1. Obviously, we have to at current index we should have higher value than the previous values in order to get the result. Now you don't have to return the simple dp, you have to return the maximum out of which, because it may not be at the last index, it may not be at the first index, it may be at the any of the index of the dp. Okay, since dp is of n length n, it can be at the result of our result can be at any of the length. Okay, so that is why we are selecting the maximum of the dp. Now I will submit it for you. Okay, yeah, it is able to solve the question, although it takes less time because it can be solved in much less complexity, time complexity with, but for make it easier and to include the dp, we are compromising that. So I hope you enjoyed it. Thank you, have a nice day.